This is the Drone Swarm multi-threading project. So right now we have 3 computers, these 2 are running on Raspberry Pis hooked up to monitor and keyboard with the antenna hooked up. This is a virtual Pi running on the laptop, and it has the same antenna. It is the only requirement for using the VirtualBox aside from the memory requirements. We are about to launch the programs on all 3 of them, and then they will connect to a Batman network. So right now they are all configuring the network, and then it will launch the program in a separate window. As you can see, I'm going to expand it on these 2. And so right now it's sending initialization packets to each other robot, and once they're all connected, they will begin simulated flight. So it sometimes can take between 5 and 30 seconds to connect, but once it connects, you can see that it is running the code on all of them in sync. They should all be navigating in the same area through virtual flight, and you can see that it is logging all of the things. That is one of the things we added to the existing code, is we added the logging file that calls functions within it. So it is telling you when it's calculating waypoints, it's telling you when it's receiving or sending update packets, and so as long as there are no fatal disconnects, it will continue to send and receive information, and they will continue traveling in a straight line. They will occasionally choose to do a swap check, which is where it determines whether or not the lead drone should remain the lead drone, because the lead drone has the most work to do, and so they actually will dynamically swap places in order to keep the one with the highest battery in the head, give or take a margin, because it takes some energy to swap drones. So you may even see it swap a few times. In the lead drone is defined up at the top of each of these packets it displays. So they should continue flying forever. Occasionally there is a disconnect where one of the drones will fly off by itself. That is simply a networking error. And right now all of the communication is taking place in the thread function we created. And so that is one of the things that has increased stability. It used to not be able to even get to this point, but now it is capable of running consistently. Sometimes one of them has an error, but rarely do we have a complete breakdown of the network. And so everything is being logged, everything is being filed, and right now the biggest issue is with the node tree, which is what's updated every time there's a send and receive packet. There's a deep error in there that is the only thing that seems to be causing the errors, but thanks to the reporting functions we have created, you can tell exactly when it does crash, and we have in fact created reporting within the node tree in order to catch that. But right now it looks like it's completely stable and running at 100% efficiency. That's all I got.